Now, if you look at a gas which is enclosed in a container, clear? Now, these gas particles, the molecules of the gas, are in constant random motion. So these particles will move, they'll collide, they'll move randomly, collide with each other, collide with the walls of the container, and so on. Now, so what happens here is gas particles or gas molecules move randomly and collide with each other and with what? And with the walls of the container. Now, when they collide with the walls of the container, are they going to exert a pressure, a force? When something collides with another thing, a force is going to be exerted. Can you understand? So, this exerts a force on the walls of the container. Is that clear? And now, this is the first point. This is the second point. Now, the third point is the force per unit area of the container is the pressure exerted by the gas. Can you understand what's happening here? Why gases exert pressure? Now, what Boyle was a scientist who studied the relationship between change in volume and pressure of the gas. Now look here, suppose this is a gas in a container and let's say there are 1, 2, 3, 4, 5, 6, 7, 8 molecules of the gas. Now, is this gas going to exert some pressure? Because the molecules are going to collide with the walls, they're going to exert some pressure. Now, this is the pressure, we call it P1, when the gas is in this container. And the volume is called V1. We'll see what this means, okay? Now, this same gas, we are not changing the mass of the gas. The same mass of gas is now squeezed and it's compressed into a container which is half the volume. So now what will happen to the gas molecules? Will they be further apart or will they come closer together? But they'll have the same number of molecules, 8 molecules now, still. So now you see the molecules are closer together, right? Now will the pressure increase or will the pressure decrease? The pressure will increase. Do you know why? Now, since the molecules are closer to each other, the number of collisions per unit area of the wall will increase. So the pressure will increase. When force increases, pressure will increase. So now here, this is pressure 2. We call it P2. And this is volume 2. We call it V2. It's smaller. Now, what Boyle said was that the pressure of a fixed mass of a gas is inversely proportional to its volume at a constant temperature. So if temperature is constant, if you decrease the volume, the pressure will increase. If you increase the volume, the pressure will decrease. Opposite will happen. This is what Boyles said. And this is what we call as Boyle's law. Now, mathematically, if you do this, there's a formula which says P1 into V1 is equal to P2 into V2. Now, in the questions that they give you, they will give you pressure 1, volume 1, pressure 2, and they'll ask you to find volume 2. 3 values will be given. You have to find the 4th value. Now, a very simple application of this is if you have water in a lake. Clear? Now, a bubble, an air bubble which forms at the bottom, as it comes up, it gets bigger. Do you know why? Because as it's rising, the pressure decreases, so the volume increases. Can you understand this? So, suppose now here the pressure is equal to 2 kilopascal, for example. And here the pressure is equal to 1 kilopascal. Clear? And here, let's say the volume is 0.1 meter cube. Clear? What will be the volume here? That's what they're asking you. Now, what was the first pressure? 2 kilopascal. Clear? What's the volume initially? 0.1 meter cube. What's the second pressure? 1 kilopascal. What's the second volume? We don't know. So, V2. So, V2 equals 2 into 0.1 divided by 1. So, how much is that? 0.2 meter cube. What happened to pressure as the bubble rose up? Pressure decreased. What happened to volume? Volume increased. The bubble got bigger. This is what Boyles said. Can you understand this? Now let me come back to the previous explanation. Why is the pressure higher here? It's because there's more frequent collisions per unit area of the container. That's why pressure increases, because more molecules are bombarding each unit area of the container, so the pressure increases, and that's because the molecules are more closely packed, not because they have higher kinetic energy. Remember, because temperature is constant. Can you understand what's happening in Boyle's law? Clear?